We are at the LeetCode website, and in this video today I'm going to solve the max consecutive ones array problem. We're going to do this in the C++ language, and hopefully I'm going to be giving you a detailed explanation of the solution to this problem, all the way from the conception all the way to when I submit it to the website and subject myself to LeetCode judgment. If that sounds interesting to you, then stay tuned. Welcome back. Now, the three main parts that go into solving a problem consist of the plan of attack, the actual code, and the analysis of said code. Before I start doing that, let me say that if you are a programmer and you're trying to prep for a technical interview, which is why this entire website exists, then go to this website, go to LeetCode, look up this problem, max consecutive ones, and try out solving the problem for yourself first. Getting the answer is great, but that's not the most critical aspect toward interviewing. Being able to convey your thought process, being able to show the interviewer your problem-solving capability, and understanding the logic of a problem well enough that you can convey and explain that to someone else is more crucial. Now, the video is still going to be here, so if you find yourself getting stuck at any point, or you've solved it and you come back and you want to compare notes, great! Video is still going to be here. That being said, let's get to it. Alright, problem is, given a binary array, find the max number of consecutive ones in this array. And they give you a little example and explanation here. Okay. Binary array, that just means that in this case it's integers that only consist of 1 and 0, which is what it says here. Length will not exceed 10,000. Okay. So, part 1, the plan of attack. Now, depending on the question, you can do anything from writing some pseudocode with comments, doodling to give yourself a little bit of a better visualization to the problem, or just talking through the logic of how you as a human being go about solving the problem. For this problem, I think I'm just going to do a talking out the logic for me. Maybe write a little bit of notes, but that's about all I'm going to do for this one, because I think that's all I need to do to grasp it. So here, being able to get the maximum number of consecutive ones, well, start at the beginning of the array, and I have to go through an array. Working through an array kind of clues me in that I'm going to need a for loop, or some kind of loop. In this case, I'm probably going to go with a for loop. I look at each position in the array, and I have to determine whether it's a 1 or not. So, looking at it, it's a 1, yes. Next position, it's a 1, yes. I have a consecutive streak, and my current counter in my mind is set to 2. Alright. But next up, I get a 0. My consecutive streak is done, and I file that away as my current maximum. But I don't know if that's my final answer yet. I haven't gotten to the entire array yet. So I continue going, picking up ones, 1, 2, 3, and I've reached the end of the array. So I've found another consecutive 1 bit, and it's 3. Now I have to compare that variable with my old answer, 2. And since I know numbers, hey, 3 is indeed bigger than 2, so that becomes my new maximum. Right? Going through the process of that, I now have a fairly good idea of how to solve this problem and the logic that goes through it. Comment that out just so I can see it and scroll down. Now we're on to the actual code. Now, during the process of going through this array, I needed to keep account of what my current value of the maximum number of consecutive ones was, and what would be my final answer. There were two separate variables that I had to keep in mind, and I was comparing those two to each other throughout the process. And whenever I hit the 0, I needed to reset my current consecutive count. So I need two variables. Integer. What am I going to call it? Let's go count ones. And I'm going to set that equal to 0 first off. Now that's going to be my current counter that's going to be reset every time I hit a 0. I also need a final answer for my maximum, so I'm going to call it max consec ones, because I'm a little too lazy to write out the consecutive all the way through. But I still want it to be descriptive, so max consec ones it is. Now, next up, I know I need a for loop, because I need to be able to go through the array. So, for keyword, and now the critical parts of it. For a for loop, there are always three parts to it. The initializer, which usually super descriptive, I. This is what initializes the for loop. It's what starts it. Next up is the condition. What are you going to compare this condition to? If it's true, the for loop, you go into it and it executes out the relevant code block that's present in it. Or if it's false, you then break out of the loop and continue on with the rest of the code within the function in this case. For this, I want to be able to go through the entire array, so I want to stop at the end. So in this case, I want to go until I is less than. Now, in order to get this next part, I need to figure out what the size of this array is. Here, I need to reference set array. In this case, because I'm working in C++, it's using the vector container, which is just an improved array. So it's called nums. So I reference nums, and I want to get a specific property of it, namely its size, the length of it, how many things this array actually contains. I do this by just saying dot size. Finally, the last part of the for loop is going to be the increment. If this is all that contains, you're going to see that you're going to be stuck in an infinite loop. It's never going to change because I is always going to be equal to 0, and I is always going to be less than the size, which is, in this case, 6. So we need a way to increase or change this I variable. Easy enough to do that. This just means add 1 every single time this for loop is done executing. So I is going to be equal to 0 at first. In C++, arrays and most containers are 0 index based. So this I for index being equal to 0 means that you start at the first position. The num's size here in this example is equal to 6. So I being less than 6, it's going to go from 0 to 5. And at a 0 based index, 0, 1, 2, 3, 4, 5. It's always one less than the size of it. So, which is why this is specifically less than. Okay, next up. What I'm going to be doing in the loop? Well, I had a condition. When I was going through this, I was looking at the integer present in each position, and I was asking myself, is that a 1 or not? So that's the condition. In this case, I need a branch, an if branch, and I need to compare that to its condition. In this case, if colon nums bracket I. So this is going to say this array that you're inputting, if I'm going to look at each position here, and I'm going to say if that value at that position is equal to 1, do stuff. What stuff do I need to do? Okay. If nums is equal to 1, then I want to increase my ones counter. So count ones, I can't spell, is going to increment. Great. Now in this, if this condition is not true, the only other thing it could possibly be is 0 in the case of a binary array. So all-encompassing, yeah, that's just going to be else. Else this is 0. I could also have done an elif and define another condition specifically saying like if nums bracket 1 is equal to 0, but I don't need to be that specific. Else is going to encompass every other possibility that isn't this specific case. And in this particular problem, that's fine and dandy. So else, what do I need to do? I need to reset this counter to 0, because if I haven't found a 1, that means I found a 0, and I need to make sure that my current counter is now back to 0, which is encompassed here. Now the other thing I need to do is if this is 1, and I've increased my count ones here, I also want to compare the max consecutive ones to count ones. So if nums is equal to 0, I increment it, and I want to now compare it. Let's do another if statement. So in this case, in this condition, I want to say if max consecutive ones is less than my current counter ones, I want to reset that and set this maximum, what's going to be my final answer, to my current count. I do that, max consec ones equals count ones, which is done by this code. So this is the equivalent and how the computer is going to handle getting to the end of this array, figuring out that the count ones is bigger than what's supposed to be my final answer. This current one, count ones, was better than my maximum. And that's not right. In that case, I need to set my final answer maximum to what my current count is. I hope that makes sense. Yeah. Moving on. So, got my for loop, got the conditions, I've got my reset here, got the else. The only thing I need to do is, because this function is an int, it's expecting me to return an integer. Now, to do that, once I'm out of this for loop, which I can see by pairing up the brackets, so I'll make sure the rest of my code is outside of that, I want to return the variable that's my final answer. In this case, max consecutive ones. Now that code should be good to go. No errors seem to be cropping up immediately to my mind. So let's get to the third part where we're doing an analysis of the code. First thing I'm going to do is hit run code, and hopefully no compiler errors crop up. Okay, good. I can see it ran the website ran this code through a test case scenario. See the input that it ran through it. And so far so good. My answer lines up exactly with its expected answer. That's great. No compile errors, no issues here. So now the difference between the submit code and the run code is this thing is going to run it through all of the test cases. So, fingers crossed, pending, judging, accepted. Woohoo! All right. Now, before I hit this button here, I'm gonna do a little bit of my own analysis of my code in terms of its time complexity. Now, time complexity can be judged by several parameters. There's omega, but a lot of the time you hear people talking about big O. In this case, the time complexity here kind of jumps out to me as big O of n because of this for loop here. I have to run through the entire array in order to be able to make sure that I have found the maximum segment of consecutive ones that's present in this array. There's no way that I can see of being able to cut corners in that. You have to go through the array. So that usually whenever you have the for loop here, that indicates that it's big O of n time complexity. In other words, it runs in linear time. N here is equivalent to saying the input size. The bigger the array, the longer it's going to take for this code to run, which makes intuitive sense. As a comparison, if you ever see big O of 1 crop up, that's even better because that indicates the 1 being a constant value that runs in constant time. So no matter how big or small the array, it's going to take this, or whatever the input is, it's going to take the same amount of time no matter what the size of the input is, which is awesome. But this one does depend on it because of that for loop, so it runs in big O of n time. Now, onto the button. Judge me, LeetCode. Okay. Interesting. So as you see here, there's a graph of the all CPP submissions, C++, and it runs from the range 20 to 130 seconds. And this is good, but take this graph as a grain of with a big grain of salt, because I'm not entirely sure how accurate it is. For instance, the servers that are running these test cases, depending on traffic use, if they're being bogged down, it might take longer to run the test cases and thus longer to run the code than it would for the very same code if it has a low traffic on it. I don't know if that's true, but personally, I take these standings with a grain of salt. Okay, middle of the road for memory distribution. But this is a fairly tight memory usage here. It's not all that much, which makes sense because in the code, in the code, you're really just having variables. You're not creating a new array, which you would need to allocate memory in a different part of the computer's RAM to do that. And I'm just kind of, even in the for loop, I'm overriding the same variables. I'm not making new ones. So yeah, it doesn't take too much memory at all. Yeah. All right. I hope you got something good out of this video, and I wish you luck walking down the path towards coding and doing well in technical interviews. And if you're interested, I'm making an entire series of this, so maybe we can walk down that path together. Okay, have a good day.